It all starts with the prompt. By training on vast amounts of information, state-of-the-art large language models are able to derive meaning and understand the world as we know it. With a single prompt, we can use LLMs as a new tool of computation. The prompt is the new fundamental unit of knowledge work, but it doesn't stop here. We can chain together multiple prompts to add and even multiply the reasoning abilities of LLMs. We call this the prompt chain. The prompt chain is exactly as it sounds. You have one prompt, and the output of that prompt becomes the input of the next prompt, so on and so forth. Prompt chaining is a powerful technique that gives your large language models the ability to reason by chaining together one prompt to the next to the next. We can also refer to previous prompts outputs in any subsequent prompt that we want. So prompt 3 can refer to our inputs or the outputs of any prompt that came before it. This creates our chained output. The prompt chain is critically important for building agentic workflows because they represent how you and I work on a daily basis. We have different tasks that we operate on throughout the day, and there's a flow to it. It may not be a straight line, but there's almost always a sequential flow to the tasks you and I execute on a daily basis. But start to finish sequences are not the only way to operate. We've explored multi-agent workflows on the channel in the past where you have one prompt firing off a loop or a set of prompts in a graph-like format. Tools like AutoGen, LangGraph, and others allow you to build workflows like this. As we've discussed, I recommend staying close to the metal. You don't want to give the most important piece of technology away to a library just yet, or at least without knowing what's going on under the hood. These workflows can also drive very powerful results for your tools, applications, and products. We've explored all of these ideas in previous videos, and we're actively building out agentic workflows on the channel right now. In this video, I want to show off a new chain that is slowly starting to make the rounds and slowly starting to gain traction that can help you boost your ability to really truly utilize state-of-the-art models near their maximum capacity. Traditionally, we have a prompt chain operating from left to right. We can take this and simply multiply the chains. By multiplying our individual chains, we can take our inputs and pass them to sets of model chains. The core idea here is that by multiplying the number of chains you have running on a diverse set of models, you're able to get a multi-chain output that beats out a single chain running. There's been a lot of talk of throwing more agents at the problem, throwing more prompts at the problem, effectively think step by step, and tree of thought on steroids. By passing your inputs to multiple chains, running the same or even different prompts, you're effectively getting different opinions from the models that you're choosing. And when you're running the state-of-the-art models from OpenAI, Anthropic, and Google, what you're going to end up with is the best possible result you can get with the state-of-the-art models. After every model chain runs, we take the final layer and merge them together in the evaluator step. The evaluator then takes the final layer of every prompt chain and decides which one best fits the result you're looking for. This is a powerful pattern because it also forces you to decide what it means to get a great result from your prompts and your prompt chains. It's also important to note that your evaluator can also be in itself another prompt call or even a prompt chain call. But the end purpose is to take all the results from your prompt chains and fuse them. This is called the fusion chain, also known as beam or the competition chain, depending on how you evaluate and combine your last layer of prompts. So this is the powerful prompt chaining technique that I want to share with you today. But first, I want to dig into a couple of key questions that if you've been working with LLMs, writing prompts, writing some prompt chains, you've probably had one or more of these questions yourself. Let's start with some of the heavy hitters. does adding 2 or more chains actually improve performance? We're going to answer this question, and we're also going to answer, won't GPT-5, Claude 4, and Gemini 2 outperform prompt chains outright, making them completely irrelevant? We're also going to take a look at the question, what's the optimal flow of prompts for agentic workflows? This is something that I think about more and more every day with every agentic flow that I build out, with every prompt chain and AI agent and tool call and function call. I keep wondering, what's the optimal flow here? Are prompt chains important? Will they be relevant in the future? These are questions we're going to answer in just a second here. Last question, we're going to look at a concrete example of fusion chaining. Let's go ahead and just answer some of these questions based on all of our experience here on the channel and in the background as we're just building out prompts, prompt chains, agentic workflows, etc. So first things first, does adding 2 to NX chains truly improve performance? The answer here is a concrete 100% yes. You can check out previous videos to kind of see how exactly this happens. But when focusing on the fusion chain specifically, you'll see something really, really interesting in this example. You can think about it like this. Instead of hiring one team of consultants to build something for you, you're hiring 3 teams. You're then concretely defining what it means to solve the problem you're trying to solve. And then you force these consultants that you've hired, every version of them, you're forcing them to compete against each other. And then you're taking the best of every single team, you're taking the best of every single workflow, and you're taking the best of every single prompt chain. I can confidently tell you using multiple prompt chains increases performance. So here's another really, really powerful, important question. The answer to this is yes. GPT-5, Claude 4, and Gemini 2 will absolutely outperform prompt chains. But the key here is that they'll outperform prompt chains of the previous generation. I can almost guarantee you that a GPT-5, let's think step by step, work through the problem over 3 prompts versus 1 prompt, that will still outperform a single GPT-5 prompt. So when we ask this question, we have to ask the question, will a GPT-5 prompt chain beat a single GPT-5 prompt, or Claude 4 or Gemini 2? And then the answer completely changes, right? This is a really, really important insight because it means that the prompt chain is a critical abstraction. It's a critical pattern. It's a higher level composition of the prompt that isn't going to go away with time, at least not without a lot more time. In the end, all technology fades away to something greater. The question is, how long will it last? Betting on the prompt chain as a key piece of technology is an absolute win. Multi-conversation chains and fusion chains, I think, are all the right direction. This is how we build powerful agentic workflows that work while we sleep. Now that leads us to another question. If prompt chains are the answer, what is the optimal flow? What's the right chain for building great agentic workflows? And I have to be honest, guys, I'm not there yet. I do not know the answer to this question. I cannot confidently say if a prompt chain with length 3 or 8 is better. I can't say if a fusion chain with 5 chains is better than 2. All I can say right now for sure is that using a prompt chain is definitely better than using a single prompt. And I can tell you that using a context-filled prompt or a BAP or a big ass prompt with 10 plus K tokens, I can definitely tell you that in most cases that will outperform a single prompt. I can't give you a prescription for, the right flow of agents to solve your specific problem. I do think that a lot of that is going to be case by case specific. It's like asking the question, what's the optimal way to build out an API? And the answer to that question is, well, what problems are you trying to solve? What information do you need to be readable, writable, updatable, deletable, right? It very quickly gets into the use cases of your specific domain. Right now on the channel, we're on a hot streak building out agentic workflows. If that interests you, hit the like, hit the sub. This is how we figure out what the optimal flow is. It's very likely that there's no one flow that fits all, but I'm very certain there's a couple workflows that will cover 60 to 80% of all use cases. All right, and then last thing here, let's go ahead and hop into a concrete example of using this fusion chain, right? And what are we doing with the fusion chain? Why is this important? Why is this so different, right? Basically what we're doing is we're multiplying the capabilities of our LLM once again. We can keep doing this horizontally by adding additional prompts from left to right, but we're exploring this new idea of blowing up top and bottom, kind of going vertical, if you will, and adding additional models to run the exact same chain and see which model wins. We're also really digging into this idea of this evaluator. A pattern that keeps coming up while building these agentic workflows is that it's super important to evaluate your responses, because something magical is going to happen here once we start truly understanding how to build these great evaluators. The evaluator is going to loop back in to the beginning of this chain and provide concrete feedback. This is where our agentic workflows are going to start thinking and operating for themselves and self-improving. Definitely let me know in the comments if you agree with my answers to these questions, or if you have tweaks or other ideas that you think need to be considered. I do think ultimately prompt chaining is a powerful abstraction that isn't going away. The big question I see is, what's the optimal flow of prompts to push your agentic workflows to the very limit with whatever current state-of-the-art models exist? So let's take a look at an API for the Fusion chain. As I mentioned on the channel, I don't like to use LLM libraries because I like to keep the distance between myself and the prompt as thin as possible. I recommend you do the same. Here's the classic prompt chain that we explored on the channel before. You can easily read this and understand what exactly is happening. You have a model, you have some context that your prompts can use. These are the inputs that we saw in the diagram. And we then have a list of prompts, and the prompts can reference the context passed in and also outputs of previous prompts. You can see here we're using output -1.title. This is coming from that exact previous prompt that just ran. That then happens again in our third prompt, where we reference both the first and the second prompt. Link's going to be in the description for the classic prompt chain. Let's move on to the Fusion chain. So the Fusion chain looks very similar to the prompt chain. Instead of passing in a single model, we're passing in n models. And now for every prompt, we're going to run our n models. So this will run a total of 9 times. And then we're passing in this evaluate function, which is going to determine the best response based on the final layer of responses from every model. We're going to rank the output from 0 to 1 so we know who performed the best. We'll take these final responses and we'll do any merging or fusing or ranking, and we'll just return the best result in the evaluator function that gets passed in to the Fusion chain. You can find the Fusion chain and the simple prompt chain in the description. Let's go ahead and look at a concrete example. We're continuing to improve the zero noise application that allows us to, without going out to look for specific information, we can hit run workflow. And this is going to go out, it's going to scrape these websites, and it's going to alert us if there are any new updates. This allows us to create a library of information and prevents us from looking ourselves, wasting time going to every single link. You can imagine having 10, 20, 30 different endpoints that you want to visit and keep track of. This tool helps you in a very low noise way look for updates for specific tools and from blog posts from specific engineers that you're interested in. So you can see here, we have an update from Simon W's blog. It does a light summary here of all the changes since the last seen date. And then of course, we have a new update from Cursor. It looks like they updated and just recently launched the beta of multi-file editing. I just saw this go out right before this video. I'm pretty excited to check that out. But anyway, you can see this tool working in action. It's a very, very low noise way to get information from blogs, from change logs, from places that you really care about. So we have an agentic workflow that runs this portion. Check out the previous couple of videos to see how exactly we built that. In this video, we're going to just look at some of the core details of this learn method because it runs the Fusion chain. So shout out to Big AGI. They were one of the only websites where I could find anything on the Fusion chain outside of hardcore research. And you can see their version of Beam here. They basically run your prompt on multiple models and then they fuse the response, right? So very similar, but it's not quite in chain form. I'm going to go ahead and link them in the description as well. Check out Big AGI. They have some interesting stuff brewing. We're going to come in here, paste this in, hit enter. It's going to run a fusion chain to determine what the best HTML selectors are in order to properly fetch the updates. And then it's going to add it to our rolling configuration file that has all these URLs. So you can see it added that there. We can now hit run workflow again, and we now have that big AGI blog in there, and we're going to see if we can get any fresh updates. So basically our learn run flow is going to find the selectors we need to run our fetch process. So you can see here, we got no updates because the last seen date is of course going to be right now. So let's go ahead and look at how this workflow runs. So you can see here we have the two workflows. This is a simple Streamlit application. We have these two workflows, and the key piece I want to show you is inside of the Agentic. So this is the Agentic workflow class structure I've been using. First, you retrieve all information that you need. So this does the initial scraping. You run your LLMs, your prompts, your AI agents. Then you act on this information. So let's go ahead and hop into the core of this in the Agentics function. You can see here, we're making sure we have raw scraped content. We're setting up the context for our chain. This is going to be the information that we pass into our prompt chains. And then we have our individual prompts that are doing the scraping. I'm going to skip over this for now. And then we have our evaluator function. So this is really interesting. But here you can see the actual fusion chain. So you can see we're passing in the state-of-the-art models, Sonnet 3.5, GPT-4o, Gemini 1.5 Pro. And then we're running fusion chain with the parallel so that these all run at the same time over these two prompts that we have here. So we have two parsing prompts, and we're running those for every prompt here. We then have our evaluator function. So this is where we fuse the response. In this case, we're just looking for the best response out of the last responses from each model chain. You can see here, I'm running some validation, and what I'm going to end up with here is a list like this. So we're going to end up with our best response, and then we're going to end up with some scores. So for every model, we're going to end up with something like exactly like this, right? So 0.25, 0.25, or 1. So it's from 0 to 1. We can go ahead and look at the fusion results right here. And if we collapse, you can see that we have the model names, and then we have our individual performance scores. So you can see every model performed at a 0.95 based on my evaluator function. In this evaluator function, we reduced 5% of their score for every header that they provided. So you can see here, I basically created a ranking system that said, I want the fewest number of headers, and whoever gives me the fewest number of headers wins. So we can see the top response here, but if we dive into all prompt responses, you can see we have a variety of responses here. This is coming from Sonnet. We have another set of responses here, right? So this one's gonna come from GPT-4o, and it gave us this, and we can go ahead and just copy one of these out. These are all likely going to be right. On the Elements tab, I can just search for this path, and you can see here, this is getting me the first 5, just like I asked, the first 5 elements that contain both a date and a summary of the blog or the change log, whatever updates they have, it's going to contain that information for me, right? So this agentic workflow automatically parsed through all the HTML here, and it gave me just this tag. And I was able to get this through the fusion chain, right? The fusion chain was able to allow me to say, hey, this is what it means to really get at this result. So that's GPT-4, and then down here you can see we have, this is gonna be Gemini 1.5 Pro. Okay, so that's basically it. You can see it gave a, kind of a totally different answer. We can see if this one works as well. Let's go ahead and just paste this in. Yep, so that answer works as well. So kind of really interesting. Something interesting that happens with the fusion chain is that you also get to see how the models perform and what different results they all give. And some of them are going to give you insights into better answers and worse answers, frankly. And that will then allow you to refine and strengthen your evaluator, right? Which then decides which one of the prompt chains has the best answer. So that's gonna be it for this one, guys. It's gonna be a longer video. I'm gonna try to cut this down as much as possible for you, but I just really think that this idea of focusing on the higher level compositions, like the prompt chain and the fusion chain, I think these are going to be really, really important ideas and really important abstractions for you to use and build really powerful technology with generative AI. So if you like the video, you know what to do. Thank you so much for watching, and I will see you in the next one.